To my video on additive relationships. So previously we've talked about proportional relationships, which shows a multiplication pattern and goes through the origin. Now we're going to see what happens when we have an additive relationship. So proportional thinking requires students to think proportionally. However, the relationship between two quantities is not always proportional, y equals mx. The relationship between two quantities could be additive. And the example being one quantity is a result of adding a value to the other quantity. And remember, we can also add negatives as well, which would be a subtraction pattern. Or we have proportional, which is what we've already learned previously, which means one quantity is the result of multiplying the other quantity by a value, or dividing. The equation for an additive relationship is y equals x plus b, where b represents the y-intercept. And I'm going to circle this right here, and let's label it y-intercept. Okay, now the slope will always be 1 in an additive relationship because, remember, the slope is the number in front of the x, but if we don't have a number here, we call it a 1 in disguise. So when you don't see a number in front of the x, it's a 1, or a slope of 1. Now let's look at an example here of an additive relationship. If you compare the x to the y, you'll see that you add a each time. Okay? And when we have a multiplicative relationship or proportional relationship, you see here all of these are multiplied by 5. Now, you might have noticed here that, yes, 2 times 5 is 10, but if you try 3 times 5, it's not 11. So that would tell us that this is not a proportional relationship, and you can clearly see we're adding 8 each time. Now let's look at a real-world example of an additive relationship. So Sarah is taking piano lessons and will learn one new song per week. When she started, she already knew how to play 5 songs. The number of songs Sarah knows how to play is represented by Y, and the number of weeks she's been taking lessons is represented by X. Complete the table and show how many songs she knows after each week, and then graph the table. Okay? So when she started, she already knew 5 songs. So at 0 weeks, we're going to have 5. Okay? Now, the number of songs, okay, she's going to learn one new song per week. So if she already knows 5, after 1 week, she's going to know 6. After 2 weeks, she's going to know 7. After 3 weeks, she's going to know 8. And after 4 weeks, she's going to know 9. Okay? And I have an X and a Y, so now I can graph. So I'm going to just put these together as an ordered pair. And remember, when we write ordered pairs, we put them in parentheses. Okay, now we're going to take those 5 points and we're going to graph them right here. So 0, 5, remember we don't move left or right, and we go up to 5. Okay, remember we're graphing here. Okay, we're not doing slope, we're graphing, so we're doing X and Y. So 1, 6 is right here. 2, 7 is right here. 3, 8. And finally 4, 9. Okay, we're going to connect those points. And since we don't have negative weeks, I'm not going to put arrows on both ends. I'm just going to put it on the one end here. Okay? So let's see if this is an additive relationship. Okay? Am I adding the same number each time? Well, I can see from 0 to 5, I add 5. Is 1 plus 5, 6? 2 plus 5, 7. 3 plus 5, 8. 4 plus 5, 9. And the answer is yes. So therefore, this is an additive relationship. And the rule is we're adding 5 to the x, so it's going to be x plus 5. And here's another way we could have seen that the ending is going to be plus 5. It does not go through the origin. It actually touches the y-axis at positive 5. So our rule for this one, and I'm going to scroll down here, is x plus 5. Okay, go ahead and turn the page. And our next word problem is Alexis can swim 8 yards in 4 seconds. The number of yards Alexis can swim is represented by y, and the seconds are represented by x. Complete the table to show how far she can swim in a certain amount of time, and then graph the table. Okay, so we know that Alexis can swim 8 yards in 4 seconds. Okay, so we can fill that up. Now, we want to know how far she can run in 1 second, and then once we have that information, then we can fill out the rest. So, if we want to know yards per second, we can take the yards, which is 8, divided by seconds, which is 4. And what's 8 divided by 4? It is 2. So, it's 2 yards per second, and I can use the slash for instead of writing the word per. Okay, so that means 2 yards every second. So 1 second is 2 yards. So what do you think at 0 seconds? Right, she wouldn't have run anything. So every second, 2 more yards. So 2 seconds is going to be 4 yards, and 3 seconds is going to be 6 yards. Okay, so now we're going to graph this situation. And I'm not going to write the ordered pairs this time. We're just going to group the x and y together. So this is 0, 0. The next one is 1, 2. So 1, 2. The next one is 2, 4. The next one is 3, 6. And finally, the last one is 4, 8. Okay, I'm going to use my ruler to connect here. And we're not going to have negative seconds, so we're not going to put arrows on both ends. This time you can see it goes through the origin. And we know if it goes through an origin, it's a proportional relationship. So is this additive? No, it's not. So we've got to figure out what we're multiplying by. Okay, we can do this a couple different ways. We can find the slope, which is rise over run, so up 2 over 1. And what's 2 divided by 1? Good, 2. Or you could just look at your table and see how are you getting from the x to the y, and you can clearly see that you're multiplying each x by 2 to get the y. So our equation is y equals 2x. And this was not an additive relationship. Okay, let's move on to number 3. Oops. So now we have a table, and we're going to, once again, tell whether or not it's an additive relationship, and then we're going to write the equation. So to do this, we're going to find the slope. So let's go ahead and look at the first example, and we're going to find the slope. Now, remember, you don't always have to pick the first two, and you don't have to do all of them, so I'm going to pick an easy one to do, 0 to 8, and that's plus 8. And 0 to 2 is plus 2. Now remember, when we're finding slope, we do rise over run, or change in y over change in x, so I'm going to write 8 over 2. What's 8 divided by 2? It's 4. Okay, so the slope is 4. Okay, so let's see if it is in fact multiplying by 4 each time. So is negative 2 times 4 negative 8? Yes, it is. Is 0 times 4 0? Yes, it is. Is 2 times 4 8? Yes, it is. And is 4 times 4 16? Yes, it is. So we're multiplying each time, so this is not an additive relationship. And since we're multiplying by 4, the rule is 4 times x. So y equals 4x. And let's look at our last example. We have, it doesn't look like we have real easy anywhere, but if I look here, I can see that I'm going up by 2, so I'm going to choose these. And negative 2 to 0, I also know that I went up by 2. So here, my slope is going to be change in y over change in x, so 2 divided by 2, which is 1. So I know the number in front of the x is going to be a 1. Okay? So if the slope is 1, unless it's going through the origin, which we know it's not right here, then we're going to have an additive relationship. So let's look at the x and see how are we getting to the y. And it looks like we're going down. And if I look here, this might be easiest to see. From 8 to 1, I'm going down by 7. So the rule is going to be x minus 7. And let's double check it here. If I subtract 7, I get negative 9. 0 minus 7 is negative 7. 3 minus 7 is negative 4. And 8 minus 7 is 1. Okay, so remember, when you have a slope of 1, there's a good chance it's going to be an additive relationship, because the only time it wouldn't be is if the graph went through the origin. And if it went through the origin with a slope of 1, then it would just be y equals x, because all the x's and y's would be the same value. That concludes our notes on additive relationships. I hope you have a great day.